Bucka, 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 bucka. Ha ha. You know the deal.
Before we talk about solving equations, we have to talk a little bit about what's called opposite operations and the effect of opposite operations. So on the board here I've put a few examples where we take a number, we do an operation to it, and then we do the opposite operation. So for the first example, we take the number 5 and we're adding 2 to 5. But then we're doing the opposite operation, and the opposite of addition is subtraction, and we're subtracting the same value. So the opposite of adding 2 would be subtracting 2. And if we explore this a little in terms of the solution, well, 5 plus 2 is 7, and then 7 take away 2 is 5. So our final answer here is 5. Looking at the next example, again, I've started with the value. This time it's 7. And from 7 I'm subtracting 3 and then doing the opposite operation of subtracting 3. The opposite of subtracting 3 would be adding 3. If we explore this example, 7 take away 3 is 4. 4 plus 3 is 7. For our next example, again, I've started with a value, 6, and then I'm doing the opposite operation. This time we're doing multiplication and division. So I'm taking 6 and multiplying it by 4, and then the opposite of multiplying by 4 would be dividing by 4. And if we explore this one, 6 times 4 is 24. 24 divided by 4 is 6. With the next example, we're starting with the value 24. We're doing an operation to it, which is divided by 8, and then the opposite operation is times 8. If we explore this one, 24 divided by 8 is 3. 3 times 8 is 24. Now, if we look at each one of these examples, what we can see here is if we do the opposite operation, we go back to the original amount that we started with. So for the first example, we started with 5. Adding 2 and subtracting 2 are opposite operations, and we went back to 5. So what that really means is when we're adding 2 and subtracting 2, we're doing nothing to 5. These essentially cancel each other out. Now if we look at this mathematically, plus 2 minus 2 makes 0. So what we're really adding to 5 is 0. Well, 5 plus 0 is 5. So adding 2 and subtracting 2 cancel themselves out. They mean we add 0. For the next one, we're subtracting 3 and then adding 3. Again, you can see we started with the value 7, we ended with the value 7. So subtracting 3 and adding 3, again, cancel themselves out. And once again, they make 0. So what we're taking away from 7 is nothing, so we still end up with 7. Similar idea with the next one. We end up with a case where we're multiplying by 4 and dividing by 4, and we can see that we went back to the same value. So multiplying by 4 and dividing by 4 cancels itself out. Now in this case it makes 1. So 6 times 1 is 1. With the next example, dividing by 8 and timesing by 8, again, those are opposite operations. They cancel themselves out. We're left with the original value. So I've put up another example here where we're multiplying and then dividing. This time though I've written the multiplication with a bracket and the division as a fraction. So this question here we would say is 3 times 5 divided by 5. If we explore this mathematically, if I were going to go ahead and solve this, I'd start with the top. 3 times 5 is 15, and then we still have the divided by 5. 15 divided by 5 is 3. So you can see again here, if we times by 5 and then divide by 5, those essentially cancel themselves out. And in this case, they make 1. 3 times 1 is just 3. So that's a little exploration of how opposite operations cancel themselves out. So again here I've got an equal sign with a very simple mathematical statement. We're saying 12 is the same as 12. And as we saw last time, if we change one side at all, we have to change the other side in exactly the same way. So another example here is if I were to multiply this side by 2. Well, we now have a balance scale that's not balanced anymore. I've changed the right side of the equation by multiplying 2. If I want to keep this balanced, I have to do the exact same thing to the left side of the equation. Now we have a statement that's true. 12 times 2 is the same as 12 times 2. And this idea of the equal sign as a balance scale works for any operation, whether it's adding, subtracting, multiplying, or dividing. So again, here I have a statement that says 12 is the same as 12. Well, if I divide this side by 6, this statement is no longer true because I haven't done exactly the same thing on the right-hand side yet. So to keep this balanced, we have to also divide the right-hand side by 6.